Although a sleeper looks relaxed and shut down, the brain is fully electrically active. So during most of the night, there's no dreaming. But during REM sleep, there's a lot of things that happen. So the heart rate and the breathing speed up, your small muscles twitch, and your brain waves become smaller and faster, and dreaming happens. Now, REM sleep is triggered by a particular set of neurons in the brainstem in a structure called the pons, and that travels to a small nucleus in the thalamus, and from there, these waves of electrical activity come banging into the occipital cortex at the back of your head. Now, that's the area of your brain where your visual system is. So when these visual areas become alive with activity in their cells, that is experienced as visual. We see. And that's why dreams are pictorial, like a film. If the activity were banging into a part of the cortex involved in smell, then dreams would just be a smell story. But it hits the visual area, and so we find ourselves thrown into a movie. Now, if you're seeing all kinds of stuff, you might wonder why you're not reacting to that with your body. And that's because the circuitry involved in dreaming also paralyzes your major muscle groups so that you don't act out your dream. You shut down your muscles so that you can simulate world experience without actually moving your body around. And that combination crafts the experience of dreaming. The electrical waves slamming into the occipital cortex make your visual system alive with activity, and the muscular paralysis keeps you from acting out the dreams. Now, we theorize that the circuitry behind visual dreams is not accidental. Instead, to prevent takeover, the visual system is forced to fight for its territory by generating these short bursts of activity every 90 minutes or so when the planet rotates into darkness. It's a self-defense system that evolved in the face of constant competition for sensory real estate. Dreams are a screensaver. So the idea is that vision carries mission-critical information for the brain, but vision is stolen away for half of our hours. It's like we're blindfolded for half our time here on Earth. So dreams, we suggest, are the strange love child of neural plasticity and the rotation of the planet. Now, one key point to appreciate is that these nighttime volleys of activity are very anatomically precise. They start in the brainstem and they end up in only one place, the occipital cortex. If the circuitry sort of randomly grew its branches, we'd expect it to connect with all kinds of areas in the brain, but it doesn't. It aims with anatomical precision at one area alone, a tiny structure called the lateral geniculate nucleus, which broadcasts specifically to the occipital cortex. And through a neuroanatomist's lens, this is really specific circuitry, and that suggests an important role. And we suggest that role is defense of the visual system. So we call this the defensive activation theory. Now, I want to address a question that might be coming up for you, which is, what about dream content? Why do dreams seem to be about something rather than just random dots of light? Well, the important thing to understand is that the brain is a natural storyteller. When there's activity in there, it shapes that into a story of what it's seeing. For those of you who know about latent diffusion models in AI, that's exactly the same thing. So DALL-E 2 and Stable Diffusion, these are image generators, and they work by starting with random activity, and that coheres into a picture of something. In exactly the same way, the brain can't see random activity. It has to wrap that into something particular that it is seeing. Now, why are our dreams a story instead of just a picture? The key is that everything in the brain is linked by association. So when you think of a rabbit, that's linked with everything you've ever associated with rabbits. Carrots and shadow puppets and the Velveteen Rabbit and Easter and Alice in Wonderland and maybe a French restaurant that serves rabbit and Roger Rabbit and so on. This is how an associative neural network is structured. Everything is linked by association.